Welcome back to BAS 121. We're going through Chapter 11 and we're learning the Risk Solver platform to do some analysis of risk and simulation. Now, we last video we went through the outsourcing model and saw how we could do Monte Carlo simulations on it. Now we're looking at a new product development and we're looking at the more pharmaceuticals. And it's telling us it wants to create some uncertain variables. So if I call up the four more pharmaceuticals, you can see the data, and you can see I've gone in and I've added a uniform distribution here between 100 million and 300 million. I've added an R&D cost. I've made it just for fun. I made it a normal distribution because our answers are going to be slightly different than the book anyways, because they're simulations. So I put a normal distribution in here, have some fun with it. I put a normal distribution in for our clinical trials because that seemed to make more sense to me that our costs we would have some sense of a bell-shaped curve rather than it just be uniform. Market share growth, I put in a uniform distribution. And for market growth, I put in a uniform distribution. I then went ahead and hit the control key and made these all my output variables. So I go to results, output, in cell. That's where I want them all output after I run my. Then I go to my options, and I said I think they want 10,000 run, don't they? I had 5,000. I think they want 10,000. And I ran my simulation at 1, a Monte Carlo. One simulation looks good. The first question, I believe, was what's the probability that we're going to have a positive net present value? So let's go ahead and simulate this, run this once, and see what we get. Now, I'm going to close this guy or minimize him. There. And I just clicked on because it gives us, because we have 6 or 7 output variables, the machine's going to give us 6 or 7 graphs because it didn't know which output variable it is. So what I did is I just closed that and then I double clicked on the net present value cell to bring up the graph of what's happening with the net present value. And notice that there is about a 90.4% chance that we'll have a positive net present value. Now, that's a little better than what the book answer is. Different simulations, I could run a separate simulation and I'd get slightly different answers. But there's about a 90% chance that we will have a positive net present value. And you can see right here the likelihood, the way we did our upper cutoff of 0, it's going to give us this percentage, which is the percentage or the probability that we have a negative net present value is about 10%. So the second question it asked us was, well, what's the probability that you'll have cumulative favorable net profits by the 3rd year? So let's click on that. And here we want to say the lower cutoff is 0. Tell us the probability. And if we... So, probability that we will have positive cash flow by the 3rd year in my simulation is almost 0. Well, it is 0. We're always going to have negative cumulative cash flows by the 3rd year. Probably makes sense. The initial investment is around $800,000. How about the 5th year? So here we have by the 5th year, and someplace up here we can get reports and charts. And we can see there you can see, again, we could run the probability here is almost certain. We could run our net present value again and look at this guy, and we could calculate a confidence interval because we've got the standard deviation and we've got the mean. So we could be 95% confident that is plus or minus 2 standard deviations from the mean. So the average net present value is $83 billion with a standard deviation of 64. So plus or minus, that's 120 either way. So we're either going to net present value of negative 40 billion to a positive 1 to 200 billion, round numbers. So we could tell our boss we're somewhere in that range. Now that's a pretty wide range, but that's because we've got lots of variables and lots of variations going on. If we could go back to our assumptions, we would know a little more. And if we want to understand which assumptions are the most critical or have the most weight, now these are the negative assumptions. So it's B11. It's that market size assumption that is huge. Let's see, B12. B11 is R&D costs in our clinical trials. So our costs are the two most critical assumptions, which is not surprisingly. Right? This other stuff, look, it's not huge. Now, for our last question is, what is the probability that we get a cumulative? Notice there's this drop-down menu. We just saw the statistics. We can hit on percentiles, and we can see there's a 90% chance that our net present value will be 1.6 billion or more. There's a 50% chance it'll be 82 billion or more. And then if we go back to our statistics, we could calculate we got our standard deviation and we got our mean, so we could calculate a 95% confidence interval by taking a z-score for 95% confidence interval is 1.96, basically through standard deviations away. So we could calculate a confidence interval, or we could just have this do the percentiles for us. We're 95% confident that it's going to be, let's say, 2.5%, someplace between there. We said about negative 40 billion and about 200 billion, about what we calculated a little earlier. So that's more pharmaceuticals, lots of interesting stuff that you can pull from and see results. Play around with it, have fun with it, just like I did. Put in distributions. Nothing says you got to make it a uniform distribution. Part of this simulation and results is to try different things. See what happens if I change the variables. See, you can make your model interactive. We could get real sophisticated and make it off a different cell. Hope that helps. Any questions, let me know.